cases that you're going to go to for each of the polynomial functions. Okay? So if you have a degree that is even, and your leading coefficient is positive, your function will look like this. Now what I got there in green, this little squiggly, what that's all about is because I don't yet know what's going to happen in the middle. I might shift some things, move it up, move it down, stretch it. So that I don't know yet. All I know is that at the ends, they're both going to go up. Think about this. Even degree, that's like an x squared, right? We know x squareds are parabolas. But if my x squared had a negative leading coefficient, it would have been upside down, right? Which is why that one's negative. And think about the x cubed here, right? This degree is odd, so that's like an x cubed. Positive leading coefficient would look like that. But if I had a negative, leading coefficient, it flips upside down. You guys okay with that? So those are the 4 different cases of what's going to be called the end behavior. Okay? So what our job to do is to decide what the end behavior is of a bunch of different functions. I'm going to call this f of x equals negative 3x to the 5th plus 5x to the 4th minus 17x squared plus 12. Jump right into the good stuff. First of all, we got to make sure we remember what a polynomial function is. Is this, what I've got written on the board, a polynomial function?
Yes.
Yes, it is a polynomial function. Why? How do I know this is a polynomial function? It has degrees. Sure, that's one way. What other ways do I know that this is a polynomial function? There's a leading coefficient. What else do I know? The f of x just means it's a function. Has nothing to do with the polynomial. Remember, polynomial functions, if I were to look at that definition, see how I had a bunch of x's to different powers? These x's all have positive exponents, okay? That's one of the main things about polynomial. These are all positive exponents. Let's maybe write that down so you guys can remember that later on. Polynomials have positive exponents. And they're also positive integer exponents, which means I don't have 1/2 as an exponent. They're all positive, regular, whole numbers. Simple, straightforward. Polynomial. So just kind of adding that to that definition, that will help you remember, especially on your homework when you have a couple where it simply just says, is this a polynomial? You need to identify, is this a polynomial? So this one is, excellent. So here's my polynomial, and I want to identify the end behavior. It's real simple to identify the end behavior. There's 2 steps. Find the degree, find the leading coefficient. Why is the degree 5? Yes, she's right. Why is the degree 5? Because it's the highest power. Excellent. This is the highest power. Right? That's a 5, that's a 4, that's a 2.
Oh, so you just
take the highest one. The degree is you just take the highest one. Absolutely. What's my leading coefficient? Now remember, the leading coefficient is the coefficient in front of the highest power. So in this case, that leading coefficient is the negative 3. And if I were to look at those 4 different possible cases, notice that in all 4 of those cases, the degree was either even or odd, right? And then the leading coefficient was either positive or negative. So that's actually all we care about. The degree is either going to be even or odd. The leading coefficient is either going to be positive or negative. So in this case, what's my degree? Odd. Right? What's my leading coefficient? Negative. Perfect. So I don't actually care that this is positive. I don't actually care that this is 3. All I cared about was this was odd, this was negative. Does that make sense?
So you just find it over there.
And then you just look at those 4, right? You just find it. There's only 4 options. Not that hard to find, right? Narrow it down. Which one is it? That's this one?
Yeah.
You do those notations either up, down, this way?
Yeah.
This way, right? How do I know? Because I'm looking at that one over here. Odd, negative. Degree odd, leading coefficient negative, meant it went up on the left, down on the right. And we don't know what happens in the middle, so we just keep those squiggly lines because we don't know how that happens yet. Easy enough? Believe it or not, that is the answer. That's what I mean by end behavior. You literally draw that funny symbol. Right? That's it.
That's the end behavior.
That's the end behavior. And again, end behavior means I don't know what happens in the middle. I only know what happens at the end. Does that make sense for end behavior? That could at least help you remember it a little bit. All right, let's do a part B. G of x is equal to, let's do 15/7 x to the 12th plus 5x to the 7th minus 8x to the 3rd plus 17. I like these problems because I can make them up real easy. It's nice. Take a second, you guys do it. Find the end behavior. Same question. Find the end behavior. And you'll reach a point probably where you could do it in your head without writing down the degree and leading coefficient, and that's fine. I've got one vote for this. We should do the hand motion. Throw up your hands on what you think it's going to be. No, come on. Okay, I'll give you a minute. Maybe you're not done yet. Okay. I got another vote for the same.
Will we do this?
Oh, there we go. Woo! All right. So a lot of people are agreeing on the same thing. What was the degree? 12. What was the leading coefficient? 15/7 was the leading coefficient. This one was a positive. This one was even. So even positive end behavior looks like up on both sides. We don't know what happens in the middle yet.
So,
Go ahead.
your degrees can be negative?
No, my degrees cannot be negative. Always positive exponents for polynomials.
Yeah, well, that's why I was confused. So, I just don't get how to be odd.
Even or odd numbers.
Oh,
Just a number.
I'm thinking positive negative.
That's okay. It's okay.
Even or odd. Wow, that's that's all it is.
That's really, yeah, it really is that easy.
Figure it out. I was like, why?
No, it really, yeah, you're making it harder. It really is like 12 is an even number. 13 would be an odd number. That's it. All right, let me give you a part C. I'm going to call this, let's say, h of x. And I'm going to make this negative 15x to the 8th plus 3x to the 9th minus 15x squared plus 14. Take a second, you guys do this. All on your own. Don't compare with your neighbor. Who votes for this one? I got one vote for that. What about a vote for this? You votes for this? What about this? What about this?
Yeah.
Oh, we're mixed. We're mixed. See how it's easier when I do it? It's harder when you do it. Okay, so how did we figure this out? We had to first figure out the degree and the leading coefficient, right? What is the degree of this polynomial?
9.
Trick. It's trick. You see why it's 9? Not 8? The highest one, not necessarily the first one. The highest one. Right? Which means the leading coefficient is the coefficient in front of that highest power, which in this case is 3. So my degree is an odd number, my leading coefficient is a positive number. So odd and positive looks like that. That's a trick one, right? I was just making sure you guys are awake. Good morning. Welcome to math.
That's funny. I put positive. I did the right direction, but I wrote negative.
Oh no.
Well, the 15.
You wrote the negative and
Yeah.
on that, yeah. That's tricky though, because you have to think about it, right? You see that negative and you automatically think negative. Ta-da! So that's it for that problem.
You're welcome.
I'm going to make this one maybe one step better. Yeah.
So, is there a name for that shape? The cube? Other than cubes?
No.
Okay.
You can call it snake if you want. You can call it this. You gotta do the dance. I think that's what it is. No, there's not a mathematical name. No. That would be easier, but there's not.
My math teacher just called it John Travolta.
John Travolta. That's what it's called. I'm so going to use that. It's now called the John Travolta. All right. How do I find the zeros and the end behavior? So So this is just one step farther. What did we say about zeros before? I did tell you what the zeros are. What does it mean for something to have a zero? It means it's the x value you can plug in to make the whole function equal to 0. When I said find the zeros of a function, you set it equal to 0 and then solve. So it's zeros are the x values that you can plug in to make the whole thing equal to 0. Does that make sense? Zeros are the x values that you can plug in to make the whole thing equal to 0. So in this case, what are my zeros? And I'm just going to list them out. And what I'm going to do is I am going to call them x equals, and I always do that simply to remind me that they're x values, not y values. Because that can sometimes be confusing. So I want to make sure we keep those separated. So what are the zeros of this function? What could I plug in to make this whole thing equal to 0?
1, 3, negative 1.
1 and negative 3, I heard, because if I plugged in 1, that would be 0. If I plugged in negative 3, that would be 0. Is there another one?
0.
Because if I plugged in 0 right here, that whole thing would be 0. You guys see that? So listing out the zeros, that's one important part of this chapter as well. Okay, the other thing it asked me for was the end behavior. Oh, before I talk about that end behavior, remember those are the x-intercepts. So if you were to graph those, you would graph those as x-intercepts. We'll practice that today, I promise. End behavior. To find the end behavior, I need to figure out the degree and the leading coefficient, right? This one's a little bit harder, because this one's already factored, right? What's the degree of this polynomial function?
2.
I haven't heard the right answer yet.
4.
4.
Yeah.
Degree 4. How did we get 4? This is factored, right? Do you guys agree that this squared is the same thing writing that out twice? And then I would FOIL, and that would give me an x squared. And then I would distribute the x, and that would give me an x cubed. And then I would also distribute this x, and that would give me an x to the 4th.
Is that the only way though?
It's the only way is to multiply it all out. Do I actually want to multiply it out? No, that's a bad plan. That's unnecessary. You just want to imagine what it's going to look like when you did multiply it out. I would have had an x here, I would have had an x squared here, and I would have had an x here. That's a total of 4 x's. So my degree is 4. It's tricky, right? That's a tricky one. What's the leading coefficient going to be? Again, everything is factored, so everything is multiplied. This is a 1, this is a 1, this is a 1. So what's 1 times 1 squared times 1?
1.
Okay. Easy enough, right? You're multiplying them all out. This is a 1, this is a 1 squared, this is a 1. Just multiply all the leading coefficients, and you get your leading coefficient.
I'm sorry, I'm going to need to see the degree worked out.
There's 1, there's 2, there's 1. So 1 plus 2 plus 1
So
equals 4.
where is that? Because so on the ones you did before,
It was
on
already
this one,
multiplied.
say for example, it was 12, so we automatically knew where's the 4 exactly.
Right, so this was already multiplied out.
Yeah.
This was not factored. So this, when I multiplied it out, I would have x times x squared times x.
Yeah.
That's x, 2 x's, and another x. That's 4 x's. That's where the 4 is coming from. You don't see the 4. No, you're counting them all up.
Okay, but so that's you said you find that LC from
The leading coefficient was
from
the...
where your degree is. You take the one.
Right.
But that's what I'm saying. There's no.
There is.
You know
There was
exactly.
this x, and this x. So you multiply them all together to get the leading coefficient. We multiplied them all together to get the 4, so we're going to multiply them all together to get the leading coefficient.
Is that just like saying there's an imaginary one in front of the x, so there's an imaginary one on top of it, right?
Yes. One's
There's
here, one's here,
right.
one's everywhere.
When it doesn't have a number, it's always 1.
That's right. So the degree you added up, when it was already factored, you had to count how many x's there were, because I have to multiply this together to get my degree. This one was already multiplied out, so I just look at the highest power. It's a different one. It's a different one for sure.
But when you multiply it out, isn't the LC 3? See, I think we need to see it multiplied.
No, I'm not multiplying it out. That is a bad plan. If I do that, you're going to want to do that, and you're going to waste a lot of your time. I'm trying to help you out. Do not multiply it out.
Okay.
The leading coefficient wouldn't be 3. Because it would be 3 times would be the x, sure, but that wouldn't be the highest power.
I'm
The
going to multiply
highest
it out.
power
with the
one
heck
is
of
when
it.
you multiply all of the ones next to the highest power together. 1 times 1 times 1.
Okay, so
Because there's 2 ones because it's a square.
Yeah, 1 squared, 1, and 1.
We were just doing one.
We're going to do more, I promise. This is not the only problem I'm going to do today. Yeah.
You add the exponents when you multiply the
For the
coefficient.
To get the degree,
4, yeah.
and I multiply just the coefficients to get the coefficient.
Okay, yeah, that's what I meant. So it's add.
Add the exponents to get the degree, multiply the coefficients to get the coefficient. If you want to see it multiply it out, by all means multiply it out. I guarantee you this is what you're going to get.
I just did it, and yeah, it's right.
I didn't lie to you. I didn't lie to you. Let's keep going, guys. So with this degree 4 and the leading coefficient 1, the degree is even, the leading coefficient is positive, right? So what does the end behavior look like? Up on both sides. Perfect. You guys okay with that? So determine if these are zeros or not. So I'll come back to end behavior, I promise. I just want this question first. In this case, I'm not asking you what the zeros are. I am telling you 3 x values, and you have to tell me if those are zeros. So it's working it backwards, sort of. Okay. Here, I figured out what I could plug in to make this equal to 0. Right? Over here, I'm already telling you what to plug in. You have to tell me if it equals 0. That's all it is. So for zeros, again, what zeros means is you get to plug it in and you get the answer of 0.
So you just solve for all 3.
So for all 3 of them, yeah. So it's kind of like 3 different parts. So I'm going to break this up into a part A, B, and C. So it's kind of like 3 different parts. So part A is I take my first x value and I'm going to plug it into the function to see what I get. If I get 0, then my answer is yes, true is a 0. If I don't get 0, my answer is no, true is not a 0. Does that make sense? Let's plug it in. 2 cubed plus 2 squared minus 17 times 2 plus 15. See, a lot of you getting out your calculator and you really don't want to do 17 times 2. Come on. 8 plus 4 minus 34 plus 15. Come on. Come on.
It's not.
It's not. What was the final answer?
I don't know, but it's not 0.
I don't know. You're right. It doesn't matter what it is. It only matters if it's 0 or not. It didn't actually matter that it was negative 7. The point is it's not 0. So then the answer to that is 2 is not a 0 of this function. So that's the answer to my part A. And then you're going to do the same thing for the other 2 problems with these. Sorry. This is now going to be kind of like your part B. So this is now going to be plugging in negative 5 into the function. So this gives me negative 5 cubed plus negative 5 squared minus 17 times negative 5 plus 15. You can plug that in. You could do that without your calculator, right?
The only thing is,
If you wanted to, yeah.
If we had to.
if negative is cubed, does it come out negative?
Yes.
Yes.
Good question. A negative
Yeah.
cube stays negative. Perfect. So what's negative 5 cubed? 125. This would become now a positive, right? Because squared turns into positive. This is now going to be plus. What's 17 times 5?
Negative 85.
85. It should be positive 85 because 2 negatives. And then plus 15, right? So we ended up with what? 0. So is my answer 0? No. What's my answer to the question?
Negative 5 is a 0 to this function.
Yay. Negative 5 is a 0. Perfect. You guys see what that question is asking now? It's basically a yes or no question. This question is all about understanding what the 0 is.
So does that mean we know 3 couldn't be because we already found our? Or could there be more?
There could be more than 1 0, right? This question had more than 1 0. So no, there could definitely be more than 1 0. Yeah.
So if there's lots of zeros, do we have to do it for everyone? Doesn't matter if one of them came out not a 0, we don't stop.
You don't stop, you still go. Yes, you don't stop. Don't stop. Believe me. I'm always loopy in my class. This morning, in my morning class, I'm very professional. I don't know what happens with you guys. All right. So 3 cubed plus 3 squared minus 17 times 3 plus 15, right? So 27 plus 9 minus, what's 17 times 3?
51.
There you go, 51 plus 15, which gives me what? Oh, that's nice. what's my answer?
3 is a 0.
3 is a 0. Come back. Questions on that?